Says here the diagram below shows parts of the graph where P and the line y equals x plus 2, and it looks like there's an intersection point. Now with question E, it's asking us to find the value of which the angle equals 60 degrees. Now there is a point of intersection where you can see here, and I'm going to draw a line going across this way. Now there's a point where they intersect, and there's going to be an angle that occurs where theta is equal to 60 degrees. Now, what we need to do is we need to extract that information and understand that when we look at this bottom line here, there is the definition of the gradient such that m is equal to tan theta. Now, if we know that m is equal to tan theta, we can move that section up to that point of intersection, and we can say that we really just want to work out the tangent at that point, and we've got here being 45 degrees. Now, how did I know that was 45 degrees? Because this line is gradient of 1, and I know that tan 45 degrees is equal to 1. So really, I want to work out what 60 degrees is at this point, and I know my tangent is going to be either going in relation to this going this way, or it's going this way. So I'm going to add 60 degrees to this, which gives me 105. So 45 here. Okay, this is going to be 105 degrees. Or going the other way. Okay, if I subtract 60 from this, I get negative 15 degrees. So really, at this point, I'm trying to evaluate two things. I'm trying to work out the tangent for this line, for P. Okay, the tangent for P at two particular degrees, 105 and negative 15 degrees. So let's evaluate what this would be. Now, we know that P is given to us in the previous question. So P is equal to e to the power of negative 2x minus 2ex negative x plus 1. So if we find what P dash is, okay, P dash, in this case, since it's a CAS exam, you can just plug this into calculator and you get 2e to the power of a minus 2 brackets e to the power of negative 2 x. Well, actually, I'm going to call this one a in this case. Okay. And then now we're going to so this is going to be negative 2a. So we're going to make the substitution. So really, these should be x's. Okay, but we're going to make the substitution of x equals a here. Okay, so since that's the derivative, we're trying to work out where does that equal tan negative 15 degrees. And the same thing, we've got 2e to the power of a minus 2e to the power of negative 2a is equal to tan 105 degrees. And when we solve these two on the CAS, we get a is equal to negative 0.11 and a is equal to 0.6, negative 0.67. All right, now the next question is saying, find the x-coordinate of the point of intersection between the lines, y is equal to x plus 2, and find the area that is bounded between the graph and also the x-axis and the graph of P. So which area are they asking for? Well, in this case, we're looking at, so I'm just going to rub this all out. We're looking at this point of intersection, and we're going to find out what this area is. And we're going to use that and add it on to whatever this red area is here. So we're going to need to form two equations, and we'll plug this into the CAS and you'll hopefully get the correct answer. Now, firstly, you need to find out what the point of intersection is here. And the point of intersection that I've calculated is negative 0.750. So the area is equal to the integral from negative 2 to negative 0.750 for x plus 2 dx. And then we're going to add that with the area from negative 0.750 to 0 for p of x, d of x. Now, how did I know it was that? Well, remember, this is section 1, and that's section 2. And then from that point, if you plug this all into the CAS, you'll get the answer 1.088 onwards. And the key thing with this is just making sure that you understand that it's bounded by the x-axis.